Hi, everybody. This is Monica Paolini from Senza Fili, and today we're talking about Teragraph. Teragraph is an entirely new way to use the vast amount of spectrum that we have in the 60 gigahertz band, which isn't licensed in most countries, and that has not been used all that much. And with Teragraph, that might change in a quite a dramatic way. So today, I'm talking to Shishir Gupta, who is the Product Management Director of Mobile Compute and Connectivity at Qualcomm Technologies. Shishir, thanks for sharing your thoughts with us today.
Thank you, Monica, for inviting me for this interview to talk about 60 gigahertz and Teragraph. Let me start with brief introduction of myself. I'm in mobile connectivity space for last 20 years. Currently at Qualcomm, I'm head of product for 60 gigahertz and XR connectivity. Now, in the space of 60 gigahertz, Qualcomm is one of the pioneers in the 60 gigahertz technology space. We are currently shipping our fifth generation of 60 gigahertz chipset. From a business vertical perspective, we are currently focused on mobile networking, AR, VR, and wireless infrastructure space with 60 gigahertz product. Specifically in the infrastructure space, we are enabling second generation product leveraging Qualcomm's 802.11 AY chipset with Teragraph architecture.
Yes, and so let's just be clear. So with Teragraph, we're focusing on the infrastructure side, which is different from other things like WiGig, which is Wi-Fi and 60 gigahertz.
Yes, it's a
And
good question. I think Teragraph, let me just give a one-line concise answer on what Teragraph brings on table. So in short, Teragraph and 60 gigahertz addresses the need for high-speed, reliable internet connectivity at an affordable cost to the masses. If I elaborate on that, Monica, this new paradigm of work from home, education from home, and play from home emphasize the need for speed, latency, and capacity for the wireless infrastructure. Even in we were seeing this trend in the pre-COVID world, but post-COVID world has accelerated those trends. We're already seeing these trends accelerating the mainstream adoption of premium connectivity for access, which also drives the need for more capable backhaul technologies. Now, from an operator perspective, what it takes to deliver reliable and high-speed connection to home, I mean, it requires low-cost last-mile connection. So in some cases, fiber could be extremely prohibitive. They need mobile network operator need scalable wireless backhaul with a flexible network architecture and a solution that supports up to 10 gigabit per second throughput. And 60 gigahertz solve all these challenges. 802.11 AY has broad 14 gigahertz unlicensed spectrum available that provide extreme capacity and performance. Like other mainstream Wi-Fi and Bluetooth technologies, use of unlicensed spectrum enables new arenas for innovation and drive broad-based availability at scale. And with Teragraph lying a foundation for validated interoperability, you can expect a healthy ecosystem to develop to address of connecting millions of consumers to reliable and high-speed connectivity at affordable cost.
yeah, and as you say, as you point out, it's really crucial that what we do see is like there's an increase in the market need because the 60 gigahertz has been there for a much longer time, but now we have the demand, we have a use for it, and so with IEEE 802.11ay, that there is a change. So can you tell us a little bit about how is that fit into the evolution, and how is the evolution of the standard, the new features, going to meet this demand, and they both come together?
Sure. Uh, I think the high throughput requirement for Telegraph necessitate the use of 802.11 AY chipset. Now, 802.11 AY provides multiple benefits over previous 11AD standards. The couple of main improvements there are the support for channel bonding that enables a 4 gigahertz channel that results in the PHY rate up to 10 gigabit per second. There are other enhancements also in the standard that improve the efficiency. Now, Qualcomm was one of the major contributor to the 11AY spec evolution. And of course, our 60 gigahertz chipset supports all of these 802.11AY features. However, on top of it, we have also incorporated other additional features that makes 802.11AY the right technology for the infrastructure space. And I can talk about few of them here. One of the major feature we support, which is a very unique implementation, is a massive antenna array supported in a single RF module. Additionally, our chipset also support combining multiple of these RF module to enable support up to 256 antenna element into a single product. On top of it, we also implemented unique beamforming algorithm on our chipset to drive industry advancement and interoperability. So together with massive antenna array and beamforming creates a product in infrastructure space that provide extended range. And that's exactly what Teragraph is looking for.
And the range and the combination of better range and the better capacity are crucial to meet the demand at the cost that the market needs. So
Absolutely.
this is really this is a game changer in terms of what is that you can do.
Absolutely, absolutely. I think the need of the market is, as you said. I mean, the market required high throughput because high throughput is important to give high speed connectivity. That's a starting point. But on top of it, you also want to have the 360-degree coverage where the Qualcomm unique implementation comes into picture. We have also taken some of the capabilities from other standards and leverage it on our chipset in terms of beamforming. So that provides the foundational capabilities to develop Teragraph on top.
Yeah, and before we go and talk more about the ecosystem, let me ask you this: 60 gigahertz is unlicensed, and obviously, as an unlicensed technology, you allow new type of players to come in and meet that market demand, which is a great thing. But with unlicensed comes the issue of potential interference. So, how do you do to address those issues?
It's a very good question. So I think let's first talk about a couple of other dimensions of what this chip bring. So Qualcomm chipset also support diversity that allows system to choose the right RF module that has the best signal, right? And diversity combined with the mesh capabilities Teragraph provides, it gives an ability for the system provider to create alternate between the different multiple nodes as needed from a from a use case perspective. For example, you do a deployment, and after a few years, a big tree grew in the neighborhood of the node. Now, with this the diversity and the mesh capabilities, you will be able to circumvent it and find another alternative route, which is much more efficient and effective. Now, from an interference perspective, as you can imagine, because you will have multiple signals running concurrently, Qualcomm chipset also support Gole codes based implementation. And this feature addresses interference issue when there are multiple links nearby. Again, very critical for wireless infrastructure space. So combined with diversity and this Gole code implementation, we effectively handle the interference issue. Another very important topic is when you are switching from between different route, you need to have extremely low latency. And that's also important for managing interference. So we have implemented features that reduce latency in switching between different TX and RX chains and different TX and RX slots. So together with all these three features on our chipset, we enable a significantly robust mitigation for interference.
Yeah, and that's really important because not everybody can have licensed spectrum where they want it. So and this is a huge advantage to create innovation in the market, which brings the issue of the ecosystem. So again, we need the demand, we need the technology, but if we don't have the ecosystem, we're not going anywhere. So and you're playing a big role in creating and nurturing this ecosystem. So can you tell us a little bit about what is that Qualcomm is doing in this context?
Sure. I think Qualcomm has made significant investment in developing wireless infrastructure market and products. We released our first outdoor 1.0 solution in 2018, and it is based on 1180 chipset. And we're currently seeing a large scale deployment of that solution in the field. Now, as the need for a higher throughput grew, we developed Qualcomm's 82.11 AY chipset for wireless infrastructure. Now, Qualcomm contribution is much more than just providing chipsets. We also developed a rich and extensive hardware software from scratch to enable wireless infrastructure use cases. And that sounds like one statement. However, that entails multiple years of effort together with Facebook to bring all the relevant features for the wireless infrastructure. We also work very closely with Facebook and OEMs to do system level testing, extensive interoperability, as well as supported multiple field trials. Uh, on top of it, as you talk about it, it's an unlicensed spectrum. So we also drove regulatory aspects worldwide with our government affairs teams across the globe. So Qualcomm is present in every aspect of this ecosystem to make sure that it enables and it becomes successful in the space.
Yeah. And so in the process of working with so many partners, from Facebook vendors and service providers, where do you see the biggest demand in terms of use cases? What are the most important use cases, and where is that Teragraph brings the most significant contribution? Because you can do many things, but where does Teragraph shine?
I think there are multiple applications for Teragraph and 60 gigahertz. Uh, from from Qualcomm vantage point, we are mainly focused on two areas: fixed wireless access and backhaul. Now, fixed wireless access, uh, I think, as I said earlier, that there's a really demand in the market for providing that affordable last mile connectivity, and that's where fixed wireless access comes in. Uh, with Teragraph, we can enable the low upfront capex deployment of fixed wireless access, where we can achieve cost cost targets of less than $200 per connection. And of course, with fixed wireless access, you don't need for trenching or ducting or wiring in the dense urban environment, which is severely constrained because of course, once it's a dense urban environment, and second, there is also a lot of municipal regulations in different part of the world. Also, uh, fixed wireless Teragraph provide capability for network to easily scale up as demand increases. And that's another important aspect of Teragraph. Each Teragraph unit can support up to 15 clients per baseband. And with mesh technology available on Teragraph, the network could be easily extended. The other important use case we are talking about and we are very excited about is small cell backhaul. As you already know that all this demand for content and demand for connectivity from home uh, really put this tremendous pressure on backhaul capacity, which is rapidly growing. And we have done Teragraph trials, which has achieved a point-to-point 1.5 kilometer range and was able to get 1 gigabit per second availability with 99.9% availability. And some of these use cases were actually done in tropical regions to account for extreme weather condition. So these are the two main areas we are focused on. Of course, there are other use cases of Teragraph in cities and smart transportation. But for us, the big ticket item from demand and need perspective is fixed wireless access, followed by small cell backhaul.
Yeah, and I guess that the sorry, the smart city, it's basically a special case of fixed wireless access and backhaul. So it sort of organically expands to other use cases.
Yeah, as we deploy fixed wireless access infrastructure, it will eventually will morph into a smart city infrastructure as well. But a starting point for us is to actually target the consumer and enterprises use cases to
Mhm.
enable them.
Now, in this case, when you think about, you can use 60 gigahertz as a sort of point to multi-point or point to point. What does Teragraph add on top of the sort of more traditional links that you could have in any, microwave, say compared to microwave technology when you have a point to point link?
I think I earlier already talked about all the goodies we are bringing from a chipset perspective. However, the hardware is not the only part of the overall equation. So we worked together with Facebook to develop a TDD and TDMA software architecture from grounds up. The TDD TDMA architecture tackles the need for symmetric uplink and downlink throughput for residential and enterprise deployment. The TDMA also delivers reliable and timely data traffic versus best effort, which has been the traditionally delivered by the other contention-based schemes. So the TDMA-based protocol combined with the time synchronized nodes capability, channel bonding coming from 11AY, massive antenna array, antenna diversity, which is delivered by Qualcomm, we can deliver high capacity coverage, help overcome large obstacles in dense urban environment, and enable connectivity at affordable cost.
Yeah. Now, another topic that I wanted to talk to you about, this is IEEE 802.11. So we are used Wi-Fi interoperability that's a big value of Wi-Fi. How does that translate to the 60 gigahertz?
Uh, so, as I said, I think what we have done at Qualcomm is to ensure that our chipset are completely backward compatible with the standards, 802.11 AY standard, and we have created the differentiations on top, right? Additionally, we have together with Facebook works together to make sure that all the Teragraph solution we are deploying could be deployed in the field without any with it's an open source, so it's available open source for anybody to take it and develop and deploy. So we are ensuring, in summary, we are ensuring two topics here. Chipset is backward compatible with the standards and to meet the standard compliance. And second, all the secret sauce we're developing on top is available open source, which could be leveraged by the ecosystem.
Right. So you combine unlicensed access, so you have access to the spectrum, and there is interoperability. It's just a protection for whoever uses the spectrum. Right now, we talked about the market demand. Why is it important now? I mean, in terms of development of standards and market. But in the last few months, and we're recording this in January 2021, we have seen a lot of press releases from all the vendors. So it seems like we really are at a tipping point in a very specific way. Why now?
That's a very good question. I think what you are seeing right now in last couple of months is a culmination of multiple years of effort by Qualcomm and Facebook. So why now? I think the technology has matured, definitely matured over the years and is ready for deployment. We have demonstrated network ability of 99.99% in real world deployment trials. We have done multiple field trials in last 6 months with 20 to 60 nodes in UK, US, and Asia. And in one of the trials, we actually deployed the Teragraph product in a live commercial network. And that was extremely successful. On top of it, as you said, multiple OEMs have launched the TG-based product, both from a distribution node perspective and the client nodes perspective. Client nodes goes into the consumer home, and distribution node is actually the hub which distribute the traffic. And the solution has been extremely well received by operator who has also been part of some of these trials, both for fixed wireless access and backhaul use cases. So in summary, I think the solution is ready from a maturity perspective, both on hardware and software side. We have OEMs launching product in the space, and we have operators ready to deploy the product in the market where there's a real need and demand for this kind of product. So it's all coming together.
Yeah, and I get a sense from talking to everybody in the industry that the technology is now mature. So a few years ago, it was more of a dream, like it was more of a plan. But now it looks like the technology is mature enough to scale, because the value of a mesh is you want to have scale. If it's only 2, 3, again, it is not a point to point to point to multi-point. You want to scale to a big deployments. Are we ready for that?
Yes, I think we are definitely seeing trend in that direction. I think few of the OEMs have already launched their product. Few others are in the pipeline. Of course, I don't want to steal the thunder from them. So we will be seeing a healthy ecosystem developing over next few months and coming quarters. And of course, there are operators which are really seeing a real world demand for these kind of deployments. A good example of that is what experience we had on 11AD deployment, where we created that product. But now, because of the demand and multiple OEMs actually collaborating and cooperating from an interoperability perspective, are seeing much higher deployment in this space. So we're expecting similar traction for Teragraph in a much bigger way, of course.
Right. Let me ask you a final question here. In terms in 60 gigahertz is available in different countries. Do you see some countries that are ahead in terms of they're more aggressive in terms of deploying Teragraph, or is it distributed among the globe?
I would say they are distributed among the globes. I think 60 gigahertz still have some regulatory challenges which we are working very closely to solve to ensure that it is more widely available across the globe. But I would say that it is distributed across the globe at this moment of time. And I think just a last comment on this. Qualcomm shares a Facebook vision in expanding high-speed internet access to the masses. And we definitely saw synergies in partnering with Facebook connectivity team with our Qualcomm 11 AY solution to develop this market and to provide an innovative solution in this space.
Yeah, absolutely. And the masses are very different in different places, and it's useful to have a technology that is sufficiently flexible to meet the demands of everybody, because there
Absolutely.
is not one type of user, there's many of them.
Exactly.
Well, Shishir, thanks so much for sharing your thoughts with us today.
Thank you. Thank you, Monica. Nice talking to you.
And thank you all for watching this. This is part of a report, a Senza Fili deep dive report on Teragraph that you can also download, and you can also read this interview if you prefer so. So thank you all so much.
Thank you.